force is constant and the motion takes place in a straight line in the direction of the force, the work done on an object by a net force is the product of the force and the distance the object is moved. Work is done in lifting the barbell. If the barbell could be lifted twice as high, the weightlifter would have done twice as much work. While the weightlifter is holding a barbell over his head, he may get really tired, but he does no work on the barbell. Work may be done on the muscles by stretching and squeezing them, but this work is not done on the barbell. Only when the weightlifter raises the barbell is he doing work on it. Some work is done against another force. An archer stretches her bowstring, doing work against the elastic forces of the bow. When the ram of a pile driver is raised, work is required to raise the ram against the force of gravity. When you do push-ups, you do work against your own weight. Some work is done to change the speed of an object. Bringing an automobile up to speed or slowing it down involves work. In both categories, work involves a transfer of energy between something and its surroundings. The unit of measurement for work combines a unit of force, newtons, with a unit of distance, meters. The unit of work is the Newton meter, also called the joule. 1 joule of work is done when a force of 1 newton is exerted over a distance of 1 meter. When carrying a load up some stairs, you do the same amount of work whether you walk or run up the stairs. Power is the rate at which work is done. A high-power engine does work rapidly. An engine that delivers twice the power of another engine doesn't necessarily produce twice as much work or go twice as fast. Twice the power means the engine can do twice the work in the same amount of time, or the same amount of work in half the time. A powerful engine can get an automobile up to a given speed in less time than a less powerful engine can. The unit of power is the joule per second, also known as the watt. 1 watt of power is expended when 1 joule of work is done in 1 second. For now, the type of energy we're going to focus on is called mechanical energy. There's 2 forms of mechanical energy: potential energy and kinetic energy. Energy that's stored and held in readiness is called potential energy, because in the stored state it has the potential for doing work. A stretched or compressed spring has a potential for doing work. When a bow is drawn back, energy is stored in the bow. The bow can do work on the arrow. A stretched rubber band has potential energy because of its position. These types of potential energy are elastic potential energy. The chemical energy in fuels is also potential energy. Work is required to elevate objects against Earth's gravity. The potential energy due to the elevated position is gravitational potential energy. Water in an elevated reservoir and the raised ram of a pile driver have gravitational potential energy. The amount of gravitational potential energy stored by an elevated object is equal to the work done against gravity to lift it. The upward force required while moving at constant velocity is equal to the weight, mg, of the object, so the work done in lifting it through a height h is the product m times g times h. The height we refer to is the distance above some chosen reference level, such as the ground or the floor of a building. The gravitational potential energy mgh is relative to that level and depends only on mg and h. The potential energy of the 100 Newton boulder with respect to the ground below is 200 joules in each case. In picture A, the boulder is lifted with 100 newtons of force. In picture B, the boulder is pushed up the 4-meter incline with 50 newtons of force. In picture C, the boulder is lifted with 100 newtons of force up each 0.5 meter stair. Hydroelectric power stations use gravitational potential energy. Water from an upper reservoir flows through a long tunnel to an electric generator. The gravitational potential energy of the water is converted to electrical energy. If an object is moving, then it's capable of doing work. It has energy of motion, or kinetic energy. The kinetic energy of an object depends on the mass of the object and its speed. It's equal to half the mass multiplied by the square of the speed. When you throw a ball, you do work on it to give it speed as it leaves your hand. The moving ball can then hit something and push it, doing work on what it hits. Note that the speed is squared, so if the speed of an object is doubled, its kinetic energy is quadrupled. It takes 4 times the work to double the speed of an object. An object moving twice as fast takes 4 times as much work to stop.